This video, we're going to take a look at the Redox Spontaneity Lab and digest and make sense out of all of the results. So if you haven't watched the video yet that has the Spontaneity of Redox Reactions Lab, so investigation 13.2, I strongly encourage you to watch that before you do this because it shows the process of adding different solutions to solid and then collects the data. So before we dive into this, I will point out that we're going to run into a new couple of terms, and they're going to get used frequently here. So we've so far studied GER, which is the gain of electron is reduction, and LEO, the loss of electrons, is oxidation. So if I had iron 3 ions plus 3 electrons became iron solid, or if I had two chloride ions becoming chlorine gas and 2 electrons, I'd have at this point been able to say that my iron 3 ion is gaining electrons and it is reduced, and that my chloride ions are losing electrons and they are oxidized. Well, we're going to add to that right now. So the iron 3 ion gains electrons and is reduced. It is the oxidizing agent. So what that means is that iron 3 is being reduced, but it will cause oxidation. So it's going to be the oxidizing agent. The oxidizing agent is a noun. It is a thing. Reduction is a process. So the iron 3 is gaining electrons. It is reduced. But the iron 3 is the oxidizing agent because it will be able to cause something else to be oxidized. LEO are A. So I've got the chloride ions lose electrons and are oxidized, which is the process. They are a reducing agent. So the chloride ions can cause something else to be reduced. So here, because my iron is gaining electrons, it can cause the chloride to lose electrons. Right? So the iron 3 is gaining electrons, it is reduced, but it causes the oxidation. So the iron 3 is the oxidizing agent. Whereas chloride loses electrons and is oxidized, but it allows iron to be reduced. So it is the reducing agent. So we're going to refer to chemicals as either oxidizing agents or reducing agents. And it's always going to be GER OA, LEO RA. Now, we're going to run into this spontaneity rule and we're going to use it later. But this applies to tables of reduction tables. We are going to build a reduction table using evidence. So now we're going to go back to our lab. So in our lab, these are some lab results that I have. And I'm going to try to identify some of the positive results. This one is a positive result. This is a positive result. This looks like a positive result, and so does this. This is a positive result. And the one that's kind of hard to see is this one. So this one is the reason that you should have abraded the surface. Magnesium gets a little oxide coating, and it's hard to react it. Now, in your lab, this was magnesium nitrate. So the ions, though, were magnesium ions. And so what I'm going to do is I'm going to transfer this information and put it into a table that looks like this. My magnesium ions, right, are here. And my magnesium solid is here. And I've kept track of my reactions in the table. They look like this. I could fill the table with the non-reactions, just put NR. Sometimes you'll see tables where the reaction is a check mark or an X equals non-reactive. So you're going to see both of those things. But what this means is that when copper 2 ion here was put on magnesium solid, there was a spontaneous reaction. When silver ion was put on magnesium solid, there was a reaction. And zinc, there was a spontaneous reaction. So each of these represents a spontaneous reaction. And a spontaneous reaction occurs without giving them extra energy. So they had enough energy to overcome their activation energy. So a reduction half reaction table is going to be organized so that they're reductions. So it's going to be, something plus electrons make something. So these are my oxidizing agents are going to be listed on the left side. My reducing agents will be on the right side. Because they're going to be reduction half reactions, we'll have electrons plus something. So that's a reduction, that's GR OA. And if I read it backwards, if I read it the other way, that's losing electrons. So LEO RA. All right, so we're going to fill in our table, but what we need to do is decide which of the oxidizing agents was the strongest. So my oxidizing agents are gaining electrons and being reduced. That's these chemicals. So which of those oxidizing agents was the most reactive? So magnesium here, if I look, is not very reactive. Copper reacted twice, and silver reacted 3 times, and zinc ion only reacted once. So the strongest oxidizing agent, the most reactive, was silver. And so I'll write its half reaction at the top of my reduction half reaction table. My next strongest is copper because it reacted 2 times, right? This reacted 3 times. So my second most reactive was copper 2 ion. So copper 2 plus 2 electrons makes copper solid. It's the second strongest oxidizing agent. And then my next strongest oxidizing agent is zinc. It only reacted once, but that's more than magnesium ion, which didn't react at all. So my zinc ion was the next strongest oxidizing agent. And then my worst oxidizing agent was my magnesium ion. So the way this table is organized is that my oxidizing agents on the left-hand side are organized from my strongest oxidizing agent to my weakest oxidizing agent. Then if I look at the reducing agents, you'll notice something over here. If I was reading across, these are my reducing agents because they're losing electrons. Magnesium reacts 3 times. Well, magnesium solid is my strongest reducing agent. And then my next strongest reducing agent is zinc, which reacted 2 times. So my reducing agents are organized, strongest reducing agent is on the bottom to my weakest reducing agent at the top. And that's how I build my reduction half reaction table. So this is the reduction half reaction table. And there is one other thing that's in this. So you might have to come back and look at this. But anytime I have an oxidizing agent like silver above the reducing agent, so it goes like this. My oxidizing agent is above my reducing agent. This is a spontaneous reaction. So if I go back to my data, did my silver ion react spontaneously with my zinc solid? Yeah, that's a spontaneous reaction. And so when I have a full table, I'll be able to decide whether a reaction is spontaneous or non-spontaneous. For contrast, if I had copper 2 ion and silver solid, so now my oxidizing agent is below my reducing agent, this will be a non-spontaneous reaction. And so if I go into my table again, I was saying copper 2 ion and silver. That's a non-spontaneous reaction. Okay, so make sure that you can follow this, create your own table that's like this, and then we're going to ask you to work on the questions in the book or in the notes. So you're going to want to do the questions related to these tables here, as well as do this. This is where we want you to get to by the end of class today.